In this question, it is given heat is supplied to a diatomic gas at constant pressure. Then the ratio of delta Q, delta U, and delta W. So delta Q is the change in heat, delta U change in internal energy, and delta W is change in work done. So since those are the thermodynamic variables, then we can write that some expression, the molar specific heat or the specific heat at constant pressure can be written as change in temperature del Q by del T constant pressure P. Again, CV, we are writing CV because change in internal energy, as we know, internal energy is basically change on the change in temperature, irrespective of the change in pressure and volume of a system. So we can easily write that CV equals to del U into del T at constant V. So from this expression, for n mole gas, since no measurement is given here, then we can take the general form for n mole gas. We can write the expression of delta Q equals to the for n mole, simple, we can multiply the mole into Cp. Then we can write n into Cp into delta T, and for delta U, change in internal energy will be n Cv into delta T. As we know, according to the first law of thermodynamics, that delta W can be written as E delta V, and since you know from PV equals to nRT, the ideal gas equation, that will be PV so equals to nRT, that means A and R is the constant, universal gas constant, so I and R delta T. So here we have the values of delta Q, delta U, and delta W. But how can we calculate the Cp? That is the specific heat capacity at constant pressure and constant volume. So we know that Cp, or before Cp, we can write the Cv equals to F by 2R. What do you mean by F? F is the degrees of freedom. So as we know, Cp minus Cv equals R. We can easily write Cp equals to 1 plus F by 2 into R. Now, how can we calculate the F, the degrees of freedom for a diatomic gas that is given? So we can write for diatomic gas, the degrees of freedom F equals to 3n minus K, where K is a constant and n is the number of particles. So here the diatomic gas, there are two atoms, so 3 into 2, 3 into 2 minus K. K is the constant, or you can say which is the constant or independent value in between them. There are only one constant, that is say 1. We have say 5. So therefore we can write that Cv equals to 5 by 2R and Cp equals to 1 plus 8 by 2, that means 7 by 2R. So if I want to write the modified expression of delta Q, then we can write here in Cp delta T, that means n 7 by R delta T, and n Cv delta T, that means n Cv means 5 by R delta T. Okay? And since nr delta T, which will be cancel out if we take the ratio, therefore we can write delta Q is to delta U is delta W equals to n 7 by 2 R delta T to n 5 by 2 R delta T to n R delta T. So if you cancel out the nr delta T part from the 3, then we can have 7 by 2 is to 5 by 2 is 1. We can write 7 to 5 to 2. That means according to the answer, we can say expression, the option number 4 is right. Thank you.